I want to quickly review one of the word equations that I saw a lot of people were struggling with, okay? And then we'll jump right into the reaction types. All right, so when we were doing the word equations the other day, okay, the biggest mistake I saw, which is usually the biggest mistake, is when you guys are reading it, you are not writing your charges, okay? I can kind of get away with not writing my charges because I kind of know them in my head. Well, I know them fully in my head, okay? But a couple of things I would suggest you do when you're writing your equations. The first thing that I would suggest for now that you do is have on the side your diatomics. So Elmer, give me one of the diatomics. Sam, you can give me another one. Cameron, you can give me another one. Josh, you can give me one. All right, Josh gave me oxygen, O2. That's a diatomic. What'd you say? Iodine. Elmer gave me iodine. Sam, Cameron, Jessica, I need a diatomic.
Chlorine 2.
Chlorine, thank you. Cl2. Was that you, Sam? That was you, right, Sam?
Br2.
Okay. Posey gave me one. Hydrogen, thank you. Charles gave me fluorine, hydrogen, fluorine.
Nitrogen.
Oops, not FL. F2. I think we're missing two more.
N2.
N2, thank you, Cameron. And Posey gave me the other one, N2, and he gave me Br2. All right, that's the first thing. If you see these by themselves, they are diatomic, okay? If they're combined with something, they don't have to have two. For instance, all right, when we look at that, okay, that oxygen doesn't have to have a two. That H has to have a two for this formula, but not because it's hydrogen, okay? So that's just, I just want to remind you of that, okay? All right, that's only if you see them by themselves. Those are your diatomics, all right? Now, the word equation that you guys were working on the other day said, let me just make sure. I think it said sodium oxide. Where is it?
I'm lucky confused on those word problems. Like I really don't get them.
Okay, let's look at one of them from the other day. That's what I'm gonna do right now. All right. So one of them said sodium oxide. This is number 5 from word equations number 1. Is added to water, and then it said sodium hydroxide is produced. All right, so when I look at this, I see sodium oxide. What else do you see that's a compound?
Water.
Yep. Here's another. Oh my gosh.
There's sodium hydroxide.
Yes, and sodium hydroxide. Very nice. Sodium hydroxide is the other one. All right, so now we know there's an arrow somewhere. We know there's some plus signs. So we got sodium oxide is added to. So I'm assuming here's where my plus sign is. All right, what do you think is on the other side of the arrow? What do you guys think?
The sodium hydroxide?
Right, it says sodium hydroxide is produced. Okay, so that tells me it's on the other side of the arrow. Okay, so I'm gonna have an arrow right here. This is gonna be the sodium hydroxide. It's gonna come on this side. Everything else is on this side. All right, here's where you guys are messing up, okay? Sodium oxide, even if you, let's go step by step. Somebody give me the symbol for sodium.
Na.
Na. And the charge, what's the charge? Yes, +1, okay? And oxide is what? Oh, anybody know the charge for oxygen?
Isn't it -1?
negative, not -1, close.
-2.
-2, yes. You guys have to have your, you need your periodic table for these because that's the only way you're gonna know your chart. Like I know my charges in my head, but you need your periodic table. All right. So most people are doing this. They say sodium hydroxide. What's water? Everybody know what water is? Yep, H2O. And then over here they say sodium hydroxide. So sodium, you guys already told me, was Na with a +1 charge. Hydroxide was one of our polyatomics.
Is it HO?
Close, yes, it's OH though. Yep, OH. And this one also has a -1 charge. So most of you guys are doing this and you're going right into balancing. But we need to box it when our formulas are correct. So I can tell you, I know H2O is correct for sure. All right. What about these other two? Are they correct? No, which one's wrong? The NaO is wrong. So remember, the first thing you're doing, even if you're confused by this, all right, if you're confused by this, the first thing you should do is just be like, okay, this is just asking me for the formula for this. So this is, even if we want to just go back to like just writing formulas, sodium oxide, what's the formula for sodium oxide? Okay, well, sodium has a +1 charge, oxygen has a -2 charge. Is this the right formula? Do these cancel out and equal 0? The answer should be no, correct? These do not equal 0. What would I need for these to be equal to 0? Somebody online tell me. They know
Oh,
it
you
in.
need another sodium.
I need another sodium. Very nice. Now this formula is correct. Okay, so now I can box this. Okay, the biggest thing is you guys just aren't writing your formulas right. If you don't write your formula correct, then when you get ready to go balance it, it's not gonna want to balance because your formulas aren't right. Okay, over here, this +1 -1 cancel out, so this is correct. Okay, now we can do our element inventory. Na, O, and H. Okay, then we could count. All right, Isaac, can you give me everything on this side, the numbers for this side?
1 Na on the left.
1 Na on the left,
Yes.
you sure?
On the left of the arrow? Or two.
Okay,
And then 2 O's and 2 H's.
thank you, very nice. And then Jessica, can you count for me everything on the right?
What do you
So I just want to know how many of these I have on the right.
mean? 2?
I need a number for each of these. How many NAs do you see?
1,
All right, how many oxygens
2.
on this side?
Oh, no. I thought you were just adding H2O. Only 1.
And how many H's on this side?
I see 1.
Thank you. All right. So now, let's make sure that's right. Okay. Everything looks right so far, all right? But what's going to happen is earlier, when you didn't have that 2 next to Na, it was going to throw off your balancing. So now, it doesn't matter what you balance first. I would recommend always balancing oxygen last though. Okay, oxygen can be tricky. But if we want to balance something, Elmer, what do you want to do? You have to add a coefficient, can't add anything in the box. Which one do you want to balance first, Na or H? And it doesn't matter.
Miss Payton,
Okay, yes, ma'am.
are you able to explain balancing a little bit more? Because I'm still confused on it.
We just want the numbers on each side to match. So right now I have 2 on what I'm doing is counting how many I have. There are 2 NAs on this side. That's why I put a 2 right here. There's 2 oxygens. There's an oxygen right here, and there's an oxygen right here. That's 2. And then there's 2
I get-
hydrogens right here. So that's 2. Over here, I have 1 Na, 1 oxygen, 1 hydrogen. So 1, 1, 1. The whole reason we have to balance is because law of conservation of mass says that we cannot create or destroy, okay, anything. So now we have to make sure the number of atoms on each side match. So now we can't change anything about the formula because, for instance, sodium oxide is Na2O. I cannot change anything in this box. I can't go in and say Na2O2 or anything like that because that's not the formula. So now I have to add coefficients, which are the big numbers in the front, which will go right here. So a big number here, or I can add a big number here, or I can add a big number here. That's the only thing I can do to change this equation now. So if you wanted to get, for example, if we're looking at, let's just say sodium. So this box right here, I have 2 on the left side, I have 1 on the right side. So Natalia, what would you do to get 2 NAs on the other side? What would you put in that box?
A 1.
Okay, if I put a 1 in this box, now how many sodiums do I have?
2. You put the 2 in the box.
Yes, I need to put a 2 in the box. If I put a 1 there, it's still just 1 sodium, 1 oxygen, and 1 hydrogen. So Cam said, let's try putting a 2 in the box. So let's try that. If I put a 2 here, 2 NaOHs. So that means I have an NaOH and I have another NaOH because you told me I have 2 of them. Now I have 2 NAs. I have 2 O's, and I have 2 H's. So this is now balanced. Okay, so your final equation should have been Na2O plus H2O yields 2 NaOH, okay? And when you guys get ready to take your quiz today, it's gonna ask you for coefficients. There's no option for 0 because there is actually numbers there. So for this one, you will put 1, 1, 2. Okay, you're gonna have to put the 1 in. Did everybody hear that? So nobody asked me later, like, there's no option for a 0. There is actually a 1 here, we just don't write it. There's a 1 here, there's a 1 right here, and then right here we put a 2 because that's what we needed. Okay. Does that help a little bit? Maybe.
Yeah, you made it a little easier.
Okay. All right. I'll go ahead and do the other one and then I'll jump into reaction type. So I'll do this other one too. So I'm going to clear this. Oh, I'm going to erase.
I have a question.
Yes.
Could you do number 4? Because I couldn't figure that one out.
Is number 4 the iron one that I told you guys to skip, or is number?
No, that's the methane one.
Oh, okay, okay. Oh, yeah. Okay, yeah. Let me do that one. All right. So let me do that one. I think, you know what? I think that's the one I actually meant to do. All right, let's do number 4. And then I'll just give you some tidbits on number 7, okay? Let me just clear everything. I'll rewrite mine. All right. H2N2O2. 1, 2, 3, 4, 5, 6, 7. All right. So number 4 says, okay, so listen to, I'm not gonna write this whole thing, but it says when chlorine gas reacts with methane, carbon tetrachloride and hydrogen chloride are produced. Let me see if I can copy and paste really quickly that sentence. Hold on. All right, so this was number 4. All right, it says when chlorine gas reacts with methane, carbon tetrachloride and hydrogen chloride are produced, okay? All right, so what are my different compounds or substances that you see? Anybody can tell me. Like, what's going to be part of the equation?
Methane.
Methane is one. And remember, the other day I gave you methane. I said this one was CH4. All right, what else?
Tetrachloride.
Yep, is it just a tetrachloride?
No, it's carbon tetrachloride.
Very nice. Carbon tetrachloride. That's another one. All right. Anything else?
Hydrogen chloride.
Hydrogen chloride.
Right. Hydrogen chloride.
Do we include the chlorine gas or no?
Yes, you do. And the chlorine gas. All right. So that's everything. All right. It says when chlorine gas reacts with, okay, so the reacts with is basically a plus sign, okay? And then it says carbon tetrachloride and hydrogen are produced. So that tells me they're on the other side of this arrow, okay? So chlorine gas, anybody want to tell me what chlorine gas is? It's just, let me just put out there, chlorine gas is just chlorine because chlorine is a gas. So what should I write for chlorine?
So Cl2.
Excellent. Yes. Cl, don't forget your 2. So that's the first thing that would have messed you up on here. Okay. So Cl2. All right. And that is the right formula. So I'm going to go ahead and box it. All right. Plus methane. I gave you that one. So I told you it was CH4. So that's right. I'm going to box it. And I told you the carbon tetrachloride and hydrogen chloride are produced. So that means it's on the other side of the arrow. All right. And I think I gave you hydrogen chloride, which is actually called hydrochloric acid. And I gave you that one too. I told you that one was HCl. So we just really need the carbon tetrachloride. What's the carbon tetrachloride?
Isn't tetra 4?
Yes, it is. Tetra is 4. Excellent.
Wait,
I
so would it be C for Cl?
Okay, is it C4Cl or, very nice, Charles, CCl4. So remember, if it was 4 carbons, this would say tetracarbon tetrachloride. Okay, so it's just carbon, so there's no.
Oh, okay. Okay.
Yep, just 1 carbon, 4 chlorines. Okay, and that's right now. So I'm going to box that one. All right. And then I gave you, I said HCl for the hydrogen chloride. So HCl. All right. So that's all boxed. This should have been what your formula, your skeleton equation was to start. Okay. So the biggest thing that would have messed you up here is if you didn't get your carbon tetrachloride, this formula right. Okay. Or if you forgot your 2 on your chlorine gas, right? So now, can you guys tell me what elements you see?
Chlorine.
Yep, that's one.
Hydrogen.
Yep. And carbon, thank you. Very nice. All right, so now we're gonna do our counts, okay? And then I'll tell you where most of you guys probably messed up. If you had everything right up to this point, I'll show you in a second where you probably messed up. All right, Lamar, can you give me my counts on this side, on the left side? Very nice. 2, 4, and 1. Any questions on how we got 2, 4, and 1 for these? Okay. All right. Natalia, can you give me my counts on the other side? Be very careful. You have a box here and a box here.
3 chlorines.
3 chlorides. Okay, tell me, say again.
5.
5, thank you. All right, so be careful. There's 4 here. All right, so she gave me this 4, but she saw that there's another one over here, so she gave me 5. Okay, keep going.
1 hydrogen
Uh-huh,
and 1 carbon.
and 1 carbon. Excellent. All right. So what I would do, all right, anytime you are balancing, if you see where there's something like this one, where there's a number on one side, there's whatever number on one side, and then there's a 1 on the other side, those are always the easiest ones to balance first, okay? Like
You're
you could
trying to
do this,
balance it. I'm sorry. You're trying to balance it to 0, right?
you're trying to get the same number on each side of your element inventory. These numbers need to match. So the numbers on this side need to match with the numbers on this side. So for example, carbon is already balanced. Carbon has 1 carbon on this side and 1 carbon on this side. But the rest of them are not. We got 2 chlorines on this side, 5 on this side, 4 hydrogens on this side, and 1 hydrogen on this side. So we got to get those numbers to match. Okay. All right, so the carbons are already balanced. Those are fine. The chlorines and the hydrogens are not, okay? The easiest thing to balance first is the hydrogens, because one of the numbers is a 1 and then the other one is whatever else, okay? Up here, you got a 2 and a 5 and you could balance that, but it's easy to do the ones that have a 1, okay? Because if I have 2 on one side and 1 on the other side, then I just need to put a 2 on this side. Or if I have 3 on this side and 1 on this side, then I just need to put a 3. So with that being said, how do I balance my hydrogens? What do I need to put? Remember, you can only at this point now put a coefficient in front of the box. You cannot change anything in the box. That's why we draw boxes around it. You can put a number here. You can put a number here. You can put a number here, or you can put a number here, a big number, which is called a coefficient. All right, so let's start with hydrogen because it has a 1 on one side and another number, which happens to be 4 on the other side, okay? So what do we want to do in order to balance the hydrogen?
We put a 4 on the outside.
4 where? Tell me where you would like the 4.
Once you put it on the outside,
On the outside of what?
well, you said we can't change nothing on the inside, so put it on the outside of C8, a CH. Oh wait, no, you put it on the outside of CCl4 or no?
All right, if I put a 4 here, is that changing the number of hydrogen?
Oh no, that didn't change. You had to put it on CH4, right? Because that's or oh no.
But aren't we, what are we trying to balance though?
Hydrogen.
Is there any hydrogen in that box?
Oh, so would it be HCl?
Yes, and so Charles, I saw your answer too, you're right. So let's put, all right, let's try putting a 4 here. So if I put a 4 here, all right, does that now give me 4 hydrogens? 4 HCl's looks like this, 4 HCl. So does that now give me 4 hydrogens?
Yes.
Yes, it does. All right, so now I have 4 hydrogens. All right, here's where people are messing up, okay? It gave me 4 hydrogens, but what else did it change?
It gave you 4 more carbon, or no? It gave you 4 chlorides too, didn't it?
Yes, it gave me 4 chlorides. All right, here's where we, all right, everybody listening, this is where people are messing up. It gave me 4 chlorines or chlorides, okay? You cannot add that to this number right here. You cannot add that to that 5. When we are doing balancing, you need to count and not add. We're only counting. So if I have 4 chlorines over here, 1, 2, 3, 4, and I have 4 here, how many chlorines do I now have? Somebody online tell me, how many chlorines do I now have?
8.
Yes, now I have 8, not 9. A lot of people were telling me they had 9 because they were like, oh, I already have 5. And then now I have 4 more. Well, you already have one of those, okay? But you just want to count again. So I have 4 chlorines. Let me just show you again where they are. there are 4 chlorines right here. And now there are 4 chlorines because this 4 gets multiplied by this Cl, because really technically there's a 1 right here. Okay. So that's 1, 2, 3, 4, 5, 6, 7, 8. So now I have 8. Okay. Now Sam or anybody, right? So now I have 4 hydrogen on this side, 4 hydrogen on this side. That's balanced. I have 1 carbon on this side, 1 carbon on this side. That's balanced. Now I have 8 chlorines on one side and 2 on the other. Okay. So I need to get 8 on the other side. Now remember, this is a Cl2. So what that really means is I have a Cl, I have 2 Cls there. How do I need 8 total. So what number do you want me to put right here?
It could be
Anybody?
1,
Say again?
1.
All right, if I put a 1 here, how many Cl2s do I have? Still looks like I just have this right now. Remember that 1 is already there. It's understood.
Wouldn't you put a 4?
Let's try a 4. Let's see what happens if I put a 4. Okay. If I put a 4 here, oops, 4 there. Okay. So that's like saying I've got 1 Cl. Here's another Cl. That's 3 Cls. That's 4. That looks like 1, 2, 3, 4, 5, 6, 7. That looks like 8 to me. Okay. Easy way is 4 times 2. That gives me the 8. So now that's 8 there. Okay. So now we have what we call a balanced equation, because now I have 8 chlorines on each side. I have 4 hydrogens on each side. I have 1 carbon on each side. This is a balanced equation. Okay. So if you were doing this on the quiz and I asked you for your coefficients, you would tell me a 4 goes here. What would go in the next box? What would go right here? A 1. And this one? Somebody online, what would go in this box right here? Because you're about to have a quiz just like that. Thank you, Charles. A 1. And then over here, you would put a 4. Okay. 4, 1, 1, 4. Those are your coefficients. Okay. All right.
Miss Payton,
Yes.
I didn't really understand the Cl2 and why you chose 4. I didn't really understand that part.
Say that one more time? Why did I put a 4 there? Is that what you're asking me?
Yeah, like I'm kind of confused on the Cl2 part.
Are you confused because it's Cl2 or because I put a 4 there?
Yeah, the 4.
Okay, so when we added, let me clear some stuff. All right. All right, so the reason why we put a 4 there is because when we were balancing, all right, we started with hydrogen. That's the first thing we balanced. Did you understand why we put this 4? Do you understand why we put a 4 right here?
Yeah, I understood everything up until the 4 Cl2 part.
All right, we put a 4 here, right? That gave me 4 hydrogens. How many chlorines did it give me total on the right side?
What do you mean?
How many? Well, I put a 4 there. I put a 4. Let me do it again. All right. We were trying to balance our hydrogens. We put a 4 right here, correct? You understood why we put the 4 there?
Mm-hmm.
To get 4 hydrogens, right? Yes?
Yeah.
Okay. So that gave me 4 hydrogens. So now I scratched out that I had 1 because now I have 4. But if I put a 4 there, doesn't it change the number of chlorines I have?
Yes.
How many chlorines do you see now on the right side?
4.
On this whole side, you see how many chlorines do you see?
5.
It's 9 now, ain't it?
No, it's not 9. All right, so you have 1.
Wait, so if
Go ahead.
you had a CO4
Uh-huh.
plus the 4 from the HCl, how would that be? Oh, plus the
Go ahead, Posey, keep going.
would it be 8?
Yes, it would. Natalia, do you see how it would be 8?
I see how it would be 8 now.
Okay. Natalia, what about you? Do you want me? Do you really? It's okay if you don't, because chances are somebody else doesn't. How many chlorines do you see right here, Natalia?
4.
How many chlorines do you think you have over here?
4.
And you see how you have 4 over here, right?
Mhm.
Okay, there's 4 HCl. So not only did it change our H's, but it changed our Cl. So that's the total of how many. We need to count them. These 4 plus these 4 is 8. Everybody understand that now? So now instead of 5, I now have 8. So I scratched through my 5 and I put an 8 there. Okay. All right. So now when I look at these, okay. When I look at these, and in a second, I'm going to start reaction types. But if you're like, I get this already, you can be working on your word equations number 2. Okay. All right. So now I still have 2 chlorines on my left side, but now I have 8 on my right. So I have to make them match. I can't get rid of the 8. I can't go down. So that 2 chlorines have to go up. I need to get it to 8. Okay. So I have a chlorine, Cl2. Remember, it's just a twin. So there's 2 Cls right there. I need to get 8 of them though. So how do I get 8 of them? They come as a set. If I put a 1 there, that's already what we got, Cl2. If I were to put a 2 there, that would be a Cl and another Cl, or a Cl2 and another Cl2. All right. If I put a 3 there, that would be another Cl2. How many Cls is that at this point?
That's 3.
How many
No, that's
Cls?
6, bad.
Yeah, 6 total. Everybody see how it's 6 total? Because you got, it's Cl2 is a twin. So there's 1, 2, 3, 4, 5, 6 chlorines. Right here, this says Cl, not Cl2, right? I'm just counting just chlorines individually, even though it comes as a twin. All right. So what number do I need to put here for me to have 8? How many Cl2s do I need for me to have 8?
4.
4. I need 4 of those. All right. So I'm going to put a 4 here. All right. Which essentially is saying 4 Cl2s. Anytime you have a coefficient, you can just multiply it by your subscript to see how many you got. Okay. So that's like if I said 2 C2H3O2s, that tells me I have 4 carbons, 6 hydrogens, 4 oxygens, because I have a C2H3O2 and I have another C2H3O2. So that's 4, 6, 4. Okay, so coefficients, you can multiply them by your subscripts to figure out how many you got. Is that better? Did that help?
Yeah.
Kinda, or
So the answer would be Like 4 Cl2 plus 1 CH4, like that.
Yes. Correct. So the balanced equation is 4 Cl2s plus 1 CH4 yields 1 CCl4 or 1 carbon tetrachloride plus 4 HCl. Okay. All right. Questions? All right. Really quickly, the last question. Let me clear. All right, really quickly, this last one. I'll write the equation for you, but then you can, later on, you can balance it. The last one from the first one was this one. All right. Don't forget we had our diatomic on the side. Our diatomics were H2, N2, O2, Cl2, F2, Br, 2I, 2, 1, 2, 3, 4, 5, 6, 7. All right, iodine crystals is just iodine. Do not forget that this is a diatomic. React with, that means
Chlorine gas.
Very nice. Chlorine gas. What am I going to write for that?
Wait, is that the one with like CH4 or no?
Nope, just chlorine. Just chlorine.
Wait, so when do I write? That's methane. Okay.
Yep. Is this right for chlorine?
Yeah. No, would it be Cl2?
Yes, Cl2. And then iodine trichloride.
Would it be I2 or would it be ICl3?
Very nice. All right. If you didn't have your diatomics here, then that probably would have messed you up. ICl 1, 3, 2, 2, and you would go in and balance it. Okay. So that's that one. All right. So any questions on that one? I didn't balance it, but you just have to balance it. Okay. All right. We're going to take some really quick notes on reaction types, and then I'm going to give you the rest of today to work on stuff, okay? All right.